Hello, everybody. I'm Sushaan, DevRel at Humanity Protocol. And today I'm going to be going through how we can build build applications on privacy-preserving identities, and how we at Humanity Protocol are making this a reality. Just to begin with, let's just kind of understand the identity crisis that exists not just in the Web3 world, but also in general. I'm pretty sure all of us here are aware of the kind of control and the amount of centralization that exists in the current world with large organizations and governments having complete control of our personal data and IDs. And with data being the new oil, every single day we hear news of all kinds of data breaches and leaks. Sometimes it's large organizations kind of trying to monetize on our data, or it's just because of the central point of failure of these large organizations. And also in Web3, we have a huge lack of robust identity mechanisms to really filter out the Sybils that are kind of interacting with our chains or platforms every single day. And to really solve this problem, we need to figure out a way to incentivize and reward the right users who are real human beings. And that's where we come in. At Humanity Protocol, at the most basic layer, we have the humanity layer, which, utilizing proof of humanity, our goal is to begin with ensuring that the decentralized ID or the wallet address that's interacting is an actual human being. And beyond that, once we know that it's a real human being behind the wallet address or the DID, we can further associate that wallet address or DID with all kinds of verifiable credentials for interacting with different ecosystems. And how do we really figure out if it's a real human being associated with that DID or wallet address? I mean, we could go with multiple approaches there's the software and hardware approach, where if you want to go with the software path, we can use AI, machine learning algorithms, and other ways like social reputation scores, etc. But eventually, as AI and technology progresses, I mean, even at this point, we can see how difficult it is to really filter out Sybils, and Sybils and attackers and whoever intend to attack the system can figure out multiple workarounds for all these safeguards that we try to put with just software mechanisms. And that's why we chose to go with a hardware approach. And coming for the hardware approach, biometrics of course is the best approach, and for that we had to keep few goals in mind. The first would be that, of course, it's sufficiently accurate in terms of identifying that it's a unique human being and there's no overlap with multiple human beings. And also keeping in mind that it shouldn't be invasive in terms of the privacy for the user themselves. So that's why we chose palm signatures, where the palm signature or the palm print or the veins of the user is like utilized to scan through and generate an encrypted biometric and associate that with a specific DID of the user. And keep in mind that this encrypted biometric signature doesn't reveal any of personally identifiable information of that specific human being. That's just verifying that it's a real human being, that they're a real human being, utilizing the DID. And once we know that it's a real human being, of course, we can utilize the fact that it's a DID that's interacting with your platform with one-to-one matching for, it's a human being that's interacting, or one-to-one matching by attaching multiple credentials associated with that DID for various use cases across the ecosystem. And this also leads to this whole concept of self-sovereign identities, where we have these self-sovereign DIDs or identities of users who are real human beings, and they have complete control over their identity, and also they have multiple verifiable credentials that are kind of independently issued by trusted parties, and they can all these credentials associated with real human beings or the DID can be verified independently either through decentralized nodes or specific applications that are verifiers. And of course, it's privacy preserving with encryption in mind for the signatures of the biometrics and decentralized storage and cryptographic proofs for proving certain parts of your DID or verifiable credentials. And to really build on top of it and understand the whole concept of kind of like attesting and attaching verifiable credentials to your DID, we need to understand the concept of verifiable credentials itself. And what are verifiable credentials? At the most basic level, they're just certain claims related to that specific DID or unique user, or just, in this case, the credential subject, which is the human user that's interacting or possesses that DID. Now, these claims can be customized, and this is where we all developers come in, and you guys can get creative and come up with all kinds of use cases to attach different kinds of verifiable credentials to that specific DID of that unique human being. And this is tamper resistant because it is signed using the keys of the user, and that specific signature of that of the verifiable credentials cannot be tampered, because if there's any small modification carried out, the whole signature is going to change, and we're going to be able to prove that it's not a valid verifiable credential. And most importantly, this adheres to the W3C standards, which is the World Wide Web Consortium standards of verifiable credentials and DIDs. Hence, it's interoperable across not just Web3 ecosystems, but also Web2 ecosystems. And of course, you got to keep in mind that we don't reveal any personally identifiable information associated with the user, but rather it's just certain verifiable credentials associated with the DID, knowing that it's a human being, and they can selectively choose to reveal parts of the details to whatever applications or entities that they trust. For an example, it could be like a driver's license verifiable credential associated with a user. Maybe they just want to reveal the age parameter. They can just go ahead and reveal that selectively. Or they just want to reveal their whole verifiable credential, that they have this license, that they possess this ID. They can just go ahead and prove it. And coming to the wide variety of applications that can be built leveraging our base layer of knowing that it's a human DID, and of course, using our SDK to build on top of it. The key aspect that you've got to keep in mind is the use cases are really broad, and you can get really creative and utilize the concept of verifiable credentials for multiple use cases. For to mention few, like universal basic income, like UBI, you know that it's a human being, and they might have certain verifiable credentials associated with them. You can go ahead and give periodic incentives to a verified human being. Or enterprise DeFi, where maybe certain DeFi protocols want to comply with certain AML or policies or regulations of specific countries. They can just selectively know that it's a user from that country, and they have these specific verifiable credentials issued by certain trusted parties or issuers, and go ahead and let them carry out the trades. And on-chain games, where, or also just games in general, where the game developer just wants to make sure that it's real human beings that's playing their game or competing, they can go ahead and utilize the DIDs provided by humanity. And decentralized signs, where verified reviewers can contribute to the progress, knowing that it's real contributors and reviewers. And further, a really interesting use case that I'm excited about, which is the network states, where we have like self-governed states, and we have these DIDs, and just with a palm scan, people can navigate through the whole network state, buy whatever they want to buy, or access certain events, or the possibilities are basically endless. And as I'm kind of running out of time, I'm just going to quickly breeze through the use cases, where we have DAOs, where we know that we can give certain amount of weightage for specific human beings, knowing that to prevent kind of like DAO attacks just through token holders of or multiple, few entities having a large control, we can just know that they are real human beings voting, and there's a majority kind of like populist kind of approval for specific proposals. And then there's RWA for linking specific verifiable credentials associated with real-world assets, and of course the education certificates issued by authorities, I mean universities, or employment proof, etc., can all be attached to the DID of that human being as verifiable credentials. Now, in terms of what we can, at this point, how developers can build on top of our SDK or API. So at the moment, we're on testnet, and we have rolled out few basic, very simple APIs to leverage the concept of verifiable credentials and issue, verify, revoke using the W3C standards. As I mentioned, the use cases, it can be broad. You can just consider one of the multiple use cases, or just get creative and think of some cool on-chain use cases. So in terms of the boundaries, we have got 2 tracks. The first one would be focused on mobile apps with really good UX and easy onboarding for the users with their DIDs on our testnet, and think of some cool use cases that where they can just show that they own this specific verifiable credential on their mobile application. Or the other track, if you want to just build like a web app and utilize our APIs, you can just go ahead and, again, get creative and build some cool use case where you utilize the verifiable credentials, and the users can do whatever you want to do based on whatever kind of dApp you're building. And coming to the judging criteria, yeah, these are like the key criteria, but to summarize, the functionality in terms of it's got to make sense, and it's got to be functional, it's got to work end-to-end, not just a half-baked project, and it's got to be a novel use case. And we're really interested in DeFi use cases because we believe that human DIDs, along with verifiable credentials, can unlock a lot of DeFi possibilities. And of course, the best practices for technical implementation and UX. In terms of UX, I think you got to make sure that it's like super easy for the users to get onboarded onto your application. So let me just quickly walk through the APIs that we have got. So yeah, so this we've got a. So if you go to our docs at docs.humani.org, you can look at the key APIs and also a few other details. But these 4 APIs are going to be crucial for, let me just show the issue part where it's very simple. We are abstracting a lot of things for y'all. So the key goal for you is to get creative with the digital claims part for the verifiable credential, where you can customize this with whatever custom claim, and the subject of the address out here is going to be the user. Sorry, I think. Yeah, it's going to look like this. And this is going to be the address on, so make sure that whatever address you're trying to verify is has signed up on testnet.humanity.org. And it's just got to be the wallet address in this case of the user or DID that you're trying to verify, attach the verifiable credential to. And you can just go ahead and yeah, this is where you get creative, and you can add any kind of custom claim associated with your use case and assign or issue the credential for that user. Yeah, once it goes through and gets issued, you're going to see the credential itself and a message saying that it's been issued successfully. So we have like a bunch of details out here, but I would like to focus here on the ID. So the ID of the verifiable credential is pretty crucial. And also here, the claims come, the claims that you attach to that. So remember that this is one specific verifiable credential associated with the DID, and the claims that you have associated with that are going to come, are going to show up out here under this section. So post that, you can just go ahead, copy this credential as such. you can just copy this credential and go to verify credential section, and this is the body of it where you just provide the credential. And once you send that, it's going to show that if it's legit or not. This is for the verification part to know that if it's a legitimate credential. Now, so this is an example of if it's not legitimate because I just revoked it. And for that, there's a revoke endpoint where, for some reason, if you want to revoke it, you can just go ahead and revoke it after a certain point by providing the credential ID. And then the list credentials where so here, you got to keep in mind that the holder DID parameter is optional. You can either choose to provide that and limit it to a specific DIDs, the credentials you have issued for that specific user, or you can just get rid of it and get all the all the verifiable credentials you have generated for your application with that specific API key. All right, so yeah, so let me quickly, So these are our docs, and if you've got any doubts, you can hop onto our Discord server or our Telegram, and we'll be around here. You can just approach us, and we'll love to help you with any doubts, or if you want to just brainstorm your idea. Also, please do scan this or fill this form. This is going to lead to the form, and we're going to reach out to you with the API key for your application. And yeah, that's pretty much it. Really excited and looking forward to all the interesting use cases that you all are planning to build on top of Humanity Protocol. Thank you so much.